Okay, students, this is our new experiment, and in this experiment, we will be learning about what is PLC and how we can communicate the PLC with the computer, and also how we can do the programming in PLC. And then after that, we will also discuss a little bit about the Scada. So PLC is basically a programmable logic controller. It is, we can say it's a mini computer that was being designed for the industrial purpose. And it was basically designed in, introduced in 1960s for the automation purpose. As you can see that it's a solid state, or we can say it's an industrial computer that is basically used for performing the discrete and execution logics in factory, or we can say in industrial environment. So the main purpose of this PLC was to replace the timers, the relays, the mechanical relays, the mechanical timers, and the mechanical counters. And then we can, with the help of PLC, we can check the input parameters and then program it, and then we can get the output according to our according to the requirement. Whatever we require, we can program the PLC according to that. So why we are using the PLC? So PLC is basically, as I told you, that it was basically introduced to replace the mechanical timers, counters, and relays. As you know, that in the mechanical thing, it is taking lots of time, to perform the operations. And so we can also do the online and offline modification. I will show you when we will be doing the programming, how we can do the modifications in the program. So it is easy to operate and less maintenance is required in the PLC. And it is very robust because you can program it, you can check the stats of inputs, you can perform the operation of according to your requirement. So we can use it in an automation industry for reducing the labor cost and all that. I'll be showing you all when I will be playing the video. So basically, there are two types of PLCs which are available right now in the market. One is called as the Modular PLC, and second is called as a non-modular PLC. So there is a difference in the number of inputs and outputs connected to these types of PLCs. So if we talk about the modular PLC, which is available right now in your lab, in this type of PLC, the number of inputs and the outputs are variable. Like we can add as number of inputs as we want. But if you talk about the non-modular type of PLC, or we can say that's a compact type of PLC, the number of inputs and the number of outputs are fixed in that. And this modular PLC is also cheaper. So as I already told you, that number of inputs and outputs can be expanded. So there is, as you can see, there on your right, there is a PLC that is being placed on, we can say, some type of rod is there. So we can add more number of modules on that, the rack type. Okay, like as number of inputs we require, we can add number of inputs on that, on that rod. Like we can add number of PLCs on that rod, and and accordingly we can add more number of inputs. Of course, when you will add more number of PLCs, you can add more number of inputs in the modular type PLC. And the second is non-modular. That it is monolithic. This is one piece. Okay, there is a fixed casing, and here the number of inputs and outputs are fixed. You cannot increase the number of inputs, or you cannot increase. You cannot add the additional power supply here in this type of PLC. This is compact. Like you will normally find it in some you will find it in labs, in some labs. This is for for special purpose applications. This is used, compact type PLC. So what are the basic components of PLC? So in PLC, we are having the input-output modules. There is a CPU, central processing unit, and also we are having the power supply and the bus system and the programming device. So this is the architecture of PLC. You can see the block diagram. You can see this. This is the block diagram of PLC. you can see like in the input we can have like switches. We can have in the input in the input section you can add the switch, temperature sensors, pressure sensors, proximity sensors, push buttons may be there, and then that input is being fed to the CPU, central processing unit, and those input, the status of those inputs is being basically read by the CPU, and their their information is being stored in the memory, and then you can program the input according to your requirement, and then finally you can execute the program. You can give that signal to the output devices and operate the device like relays, solenoid, motor, fan. You can operate anything based on your requirement. For example, you want sometimes your requirement may be, for example, after switching the push button, you want your motor should be starting after 10 seconds or 10 minutes. So accordingly, you can program the PLC, and then the operation will be performed in that way only. I will be showing you when I will be playing the video. In that, I will be showing you how we can program the PLC. Okay, as I already told you, these are some of the inputs which we can give to the PLC, like push buttons may be there, selector switches may be there, photoelectric sensors may be there, and relay contacts may be there. So any type of electrical or electromechanical inputs may be there to the PLC. And what are the output devices which we can connect to the PLC? Valves may maybe there, solenoids, lights, horns, meters, whatever you want to control. Your output may be that only. Okay, the PLC power supply is basically plays a vital role because without the power supply you cannot operate the PLC. So you had to operate the CPU, you had to operate the memory unit and peripheral devices. For that you need a power supply. So the standard power supply is 24 volts. You can give 24 volts to the PLC. And there is one more thing that is being there is an optical isolation as the input of PLC, because sometimes some short circuit may occur at the input side and should not reflect on the output side. For that there is an optical isolation in the PLC. And sometimes, as I already told you, in the modular types of PLC, we can increase the number of inputs and outputs. So for that, we may require the additional power supply. We can, there is a provision for that as well. Now, this is one of the PLCs. This is how the PLC looks like. And this is there are different vendors for the PLC. But this is the one by Alan Bradley. On the left side, you can see there is the power supply. On the extreme left, there is a power supply. And after that, there is a CPU, central processing unit. And then the rest of the modules are I/O modules, where you can connect to the input and output devices. So this is the basic, the exact figure of the PLC, how it looks like. So I have made a video on this too, and I can show you I will use a 7-minute introduction, 7 or 8 minutes. I will show you how exactly the PLC looks like. Okay, this is you might have seen it somewhere like this, like in some industries, or if you have visited some any manufacturing unit. The PLCs are placed like this only. So there are the 2 CPUs because multiple PLCs are there, and we can see on the left there is the field bus. Field bus is basically some, as I have already shown you, there are some inputs those switches and something maybe there, and those are they may be directly connected to the CPU through the field bus. And on the bottom you can see different types of buses are there, and you can connect a large number of inputs and outputs here. The serial connections are there as well. Okay, so now the very important thing in the PLC program is the PLC Program Scan, how the PLC basically works. So that is called as a scan cycle. One scan cycle consists of reading the input and then executing the program, and then it is basically communicating with the output, and then it is updating the output. For example, in the one PLC scan cycle, the PLC is reading the status of input, whether the switch is on or off, whether the the relay, whether the relay is operating there or not. Okay, the PLC will initially read its status. Okay, then that will go to the CPU, and the CPU will what it will do, it will execute that program. Okay, then you can modify that program as well. Like you want any kind of operation you want, you can modify that program, and then according to that, the output will be updated, and that consists of a one PLC scan cycle. Okay, now you already know, like for example, if there are large number of inputs, it will take large time, for the operation. So more input outputs, then more scan time will be there. So scan time is basically, it depends upon the number of inputs and outputs connected to the PLC. Okay, the normal scan time for the PLC is from 1 millisecond to 2 milliseconds, and sometimes, for the large number of inputs, it may take 100 milliseconds to 200 milliseconds for the operation. Okay, how we can figure out how we can do the troubleshooting in PLC? Troubleshooting is something like any fault occurs into the system, or if there is any problem in any part of PLC, that is called as a troubleshooting. Like how we can do that, how we can find out that problem. That is called troubleshooting. So you can see, like there are the 5 LEDs for the 5 basic things. If there is a problem in DC power supply, the power supply to the PLC, like the LED 1 will be on. Similarly, like if there is the CPU operation problem, then the LED 2 will be on. Memory fault, if there is a memory fault, then LED 3 will be on. There are some LEDs that are being placed on the PLC. Like those LEDs will glow according to the type of fault the PLC is facing. Or if there is a battery, battery is running out of supply, then in that case LED 5 will be operating. So like this is how we are doing the troubleshooting in PLC. Okay, so there are various brands of PLC. I have shown you, like the Allen Bradley. I have already shown you, like in the previous slide, and the Siemens is there. In our lab, we have a Siemens, the PLC by Siemens, that is basically from Germany, and there is two other vendors as well, like Omron, Modicon. These are the PLCs from the different countries, and the one thing that differs in all these PLCs is that their naming for the switch. For example, in Allen Bradley PLC, their naming is different for the normally open and normally closed switch, and for the Siemens it is a different naming. Naming is different, but the operation is same. This is their configuration may be different as well. So these are some brands of PLC which we are having available right now in the market. Okay. There are different types of programming language which we can program the PLC in different ways. But the basic programming which we are doing in PLC, that is called as a ladder basics. So why it is called as a ladder programming, I will let you know. When I will be doing the programming, then you will get to know that why it is called as a ladder programming or ladder. Okay. So in the ladder programming, we are normally 50 to 60% of such operations in 50 to 60% operations. We are using the normally open and normally closed switch. These are very essential. And as I told you that in Allen Bradley, those normally open and normally closed switch may be called as XIC or XIO in case of Allen Bradley. So XIC is basically examine if closed, or XIO is called as examine if open. So naming is different only. The rest is same, though, operation is same. Okay, so these are the basic symbols which we are using in PLC programming. Okay, the first symbol here, on the left, it is normally open. The symbol for normally open switch, and the second one is normally closed switch. Okay, so what is the basic functioning of this switch? the normally open switch, it is true, when the status is high, like when you are pressing it, it looks like a push button. When you are pressing it, the output will be high. When when you will drop it, the output will be low. Okay, and then there is a normally closed switch, and in the normally closed switch, it acts when it is when you are not pressing it, the output will be high, but when you are pressing it, the output will be low. It is working in an opposite manner to the normally open switch. Okay. Now, this is, for example, suppose you want to design a gate in a PLC programming. This is how you can design a gate in the PLC programming. The first two switches, these are the normally open switches, and these this bracket is shown on the right. This is for the output, and this will glow only when both of the switches will be on. Like when you are pressing both the switches, then your output will be high, otherwise it will be low. So this is the one rung. Rung is called as basically in just like in a C programming, one line of when you are writing some code, those are called instructions. Like this is how you can the type of instructions which we are using in the PLC. This is one rung. One rung is one programming line in PLC. This is the one programming line in PLC. Okay. Similarly, for example, you want to design a NOT gate in PLC. This is how you are designing a NOT gate, and this is the logic for the OR gate. You know, when any of the inputs is high, the output will be high. Okay, this is how we are doing the programming in PLC. And similarly, you know, there are a lot of other operations which we can do in PLC. Like these are some timers, timer on, timer off, and return to timer on. These are some timers which you can use in the programming of PLC. I will be using it I will be showing you in this in the video how we can make use of these timers, how you can give the time delay in the operation. So these are used for the time delay operation, giving the time delay. And similarly, we have the compare instructions, counter instructions as there there as well. So these are the compare instructions, equal operation is there. When the two inputs are equal, the output will be high only. And similarly, when the two numbers, when there is a range of when there is a number in between the lower and higher limit, the output will be high. Okay, this is the limit test you can do with the help of these. These are the programming blocks in PLC. And then after that, there is this is the continuation of the last slide, the compare instructions, not equal to operation, less than operation, greater than operation you can do in the PLC. And counter operation you can do with the with the help of counter operation. What we can do, the output will be high after a particular number of pulses. For example, you want to set the counter up counter for the 5 pulses. When the counter will receive the 5 pulses, then only after that output will be high. Otherwise, it will be low. No matter how many times you are applying it, until and unless it will not reach the desired preset value, it will not turn on. The counter down is basically working in an opposite manner to the counter up counter. So we can also do the mathematical and logical operations in the PLC. We can add 2 numbers, subtract 2 numbers. These are the basic blocks I'm showing you. We can do so many other operations as well. Okay, this is how the PLC programming window is looking like. You see, as I already told you, why it is called as a ladder programming. You see, it is looking like a ladder. 1 rung, 2, 3, 4. There are the 4 rungs. Okay, 3 rungs. Yeah, 4 rungs are there, and you see, it is looking like a ladder. This is the basic programming of PLC. There are some normally open switches, normally closed switches. There is a move operation is there. Okay, a lot of other operations are there. So this is how we are doing the programming. This is the basic programming of PLC. You don't have to write any code here. There is a provision, but you can simply do it with the logic. Like the way you are making a circuitry, the same is the case here in PLC programming window. Now, the PLC, like I will be showing you the two videos, hardly 30 minutes of videos. But before that, we will be discussing something about the Scada. What is Scada? Scada, you can see like a lot of windows are there, and one person is looking at different windows. So you might be getting an idea what the Scada is basically doing. It is the supervisory control and data acquisition system. What we are doing here in the Scada, basically, there may be some, there are some places where a person cannot, operate. So what we are doing, we are placing some RTUs, that is remote terminal units, and those RTUs are connected to the PLC, and that PLC is connected to the central computer. And there we are basically monitoring all the things. You know, the one person is supervising all the things. That is what the Scada is doing. Supervisory control. There is some supervisor who is controlling, and data acquisition system. You are getting the data from the different RTUs, and then you are processing the data. This is the basic idea of Scada. Okay, this is already what I already told you. It like supervises the entire plant, and then you can operate you can operate the PLC being far away from it, and those PLCs are connected to the centrally connected system. There is a server, and you can also operate the things with the help of internet. So you see, like what are the features of Scada? Scada is basically, you know, in the Scada, if maybe in future you may go through the Scada software. In the Scada, basically we are having with the help of graphics. You can develop the graphical environment, and with the help of that, you can supervise the things. You can check which plant is working well, which line is, for example, you are operating a transmission and distribution system. For example, like I will talk about the electrical things. You can check with the help of Scada which line is out in the state of outage. Okay, like which line is not operating. The Scada can show you with the help of these graphics. Okay, like you can, you know, a lot of things are there. It can be used for the security purpose, recipe management. For example, recipe management. I will give you an example. If you have tasted, if you have eaten the this Lay's, you know, you whatever you are eating every day, like the Lay's, or we can say the chips, 10 years before, and if you are tasting that right, if you are eating that right now, you are getting the same taste. Why you are getting the same taste? Just because of recipe management. You know, just with the help of Scada, we can adjust how much sugar we need, or how much salt we need, or how much the spices we need in a particular recipe. That is why, you know, you don't find any change in the taste of any chips or any cold drink or something like that. This is because of Scada feature. Okay, you will get it in future when you will go for internship in industry. You will get it from there. Okay, this I already told you. With the help of graphics, you can add there are options available. You can create a virtual plant, and then you can control. You can connect to that with the PLC, and then you can control everything in Scada with the help of these graphics. Okay, device connectivity. You need a driver for that, for connecting a Scada to the PLC. There you need a driver for that. So better okay. In Scada, there we have because whatever logic we are writing in the Scada, we have a logic for that as well. That's called a script. Okay, so with the help of scripts, you can develop a logic, and you can make the operation according to your requirement. Okay, this is look at this closely. This is how the Scada is exactly looking like. You know, you can see there are the graphics showing there, and different valves are there. And those valves are basically controlled by the PLC, and Scada is showing you that which unit is running, which unit is stopped, which unit is tripped, which unit is failed, I mean to say. Okay, you see the Scada is also showing you what is the water level, what kind of water level is there right now in the tank, for example. What is the temperature of that water level? Okay, this is the exact exactly you can imagine the exact figure like situation what we are using the Scada. So this is the real time the slide I'm showing you here. This is the real time like operation of Scada. Okay, and in like this is the example. You can see on your right, like different, like at the different places we are having the at the remote locations we are having the RTUs, and those RTUs are connected to the modem, and from there the data is being sent to the head office, and like we can operate then those like remote units with the help of this like with the we can like send the signal from the center to the remote area so that we can control those machineries there. So we can also control all these things with the help of like internet. We can send data through the internet to the server, and then server will operate according to your requirement, whatever operation you are giving out. You can also do the satellite communication. All you need to operate the RTUs, and those are connected to the PLCs, and Scada is basically arranging all these things, and then you are performing the operation. Okay, these are some of the leading software like Scada softwares like Wonder, where they are having the Indite, Intolution. They are like Scada software is iFix. Allen Bradley, they are having the RS View, and Siemens, WinCC, GPhonoc. These are like some of the like leading Scada softwares. So Scada you can use in the control of substations, load shedding, metering, downtime analysis, dispatch and assessment. So these are some typical applications of like industrial applications of PLC and Scada. So that's it. And if you have any doubt regarding this, before moving to the like next part, you can ask me if you have any doubt, so that I can repeat. So anybody have any doubt? Hello? Am I audible?
Yes, sir, no doubts.
Okay. Now, in the next, I'll be showing you two videos, hardly half an hour. So I will be showing the program, how we are basically doing the programming PLC, and so that you can get an idea like what actually the PLC is, how the PLC is working, and what actually the PLC is doing. Okay. This is the basic intro of, okay. This is the basic this is a unit of PLC which is available right now in your like lab. So I will be playing the video. If you're facing any issue with the audio, just let me know. Hello?
Sir, actually the audio in the video is and a lot of echo is coming from your side.
So voice is echoing, right?
Sir, the video hasn't, the audio hasn't been shared with the video. It's on mute right now, yeah. Sir, there is an option while sharing of including computer audio. You need to do that. Like share again.
Yes, yes. Imran, please unset your screen.
Sir, still no audio.
Okay, dear students, today our experiment
Yes, sir, it's audible properly now.
is based on the PLC, how the PLC looks like, and how we can communicate the PLC with the computer, and how the PLC works. This is the main part of the experiment. So this is basically the PLC, which is available right now in your lab. So as you know, the PLC is basically a digital computer which can perform the sequential operations. Basically, it was developed in 1960 so that we can replace those mechanical plays and the switch operations, the mechanical switch and those contactors and all those things, valves. Sorry, we can replace all those mechanical things. And the PLC was basically, its main purpose was for the automation. So in the 1960s, the automation started, and the PLC was introduced in that year. I mean, from the 1960s it started, and by the year 1980, the PLC was very popular because it has reduced the labor cost and it has helped in the automation of all the industrial things. So basically, we are using this PLC in the industry. It's a digital computer. Unlike the general computer, this PLC is basically designed for multiple number of inputs and the multiple number of outputs. So you see, here, this is the, first of all, I will show you how the PLC looks like. This is basically the PLC. This is the one type of PLC which is available right now in our lab. We are having two types of PLCs are there. One is compact PLC and one is modular PLC. And in the compact PLC, the number of inputs and number of outputs are fixed. We cannot add the number of inputs and number of outputs there. But in the modular type of PLC, that is the rack basic. You can add as much number of inputs as you can. But here we are having, this one is the modular type, because you can see that the rack is here, you can add the more racks and you can add the more number of inputs and outputs. You see, this portion, you see there are the 4 sections, 1, 2, 3, 4. This is the power supply for the PLC. This is from where the PLC is getting the supply, and this is the processor. You can see this is the CPU 314C2 PMDP. This is the processor which is available. This is basically developed by the Siemens, and this is the input and output section. We can add the number of inputs and outputs here. Now you can see this is basically we are having the different number of cables which are available for the for communicating the PLC and the computer, and different RS242 and so many other cables are available. And this one is the Ethernet. This cable is basically communicating the computer. Computer is there, and with the PLC, and with the help of this, we can send the data to the PLC, and PLC will, work accordingly. And now you can see there are so the PM02 cable is also available. We can add that as well, but this is available right now in our lab. So we are communicating this with the computer. And as you know, that there are 3 sections in the PLC, like the input module, output module, and the central processing unit with the power supply and memory. Now, in the input could be anything like the switch, or the switch will be there, valves will be there. It could be anything relating to this which can send the electrical signals, and the output module. We can connect to the number of outputs to the output module. The PLC operation is basically divided into the 3 sections. The first is the PLC is reading the data from the inputs, and that is the input scan, that is called as input scan cycle. And then after that, it is based on the status the CPU is reading from the input, it will execute the program accordingly, or the user can program it accordingly and perform the operation. Then that is the second stage, like the execution of program, that is the execution cycle, execution scan cycle, scan part, and then after that, that's the output scan. In the output scan, the PLC is basically sending the signal to the output, and it will operate the output accordingly. So as more number of inputs are there, it will take more scan time. Okay, usually the scan time is from 10 milliseconds to 100 milliseconds. It takes usually that much of time for the scan. And once the 1 second cycle is complete, the PLC will start again from reading the status of inputs, and then execute the program, and then update the outputs. Once the updation is done, the second cycle is complete. Now you see the PLC output is basically connected here with the number of LED like indicators. You see this panel. The connection is the output is taken here, and connected with the number of outputs. And these are some meters which can show us the reading, like voltage and current reading. You see here. This is basically the input section. The input section to the PLC. You can this may be the switch, and anything like we are having the switch here. This is the input section. We can have analog inputs. We can have digital inputs. And this is the output section. You can see the number of indicators here, and this will indicate whether our output is high or whether our output is working or not. So this is the basic panel for the PLC. You see here, this is the one more like distributed unit. We can add number of more inputs here. Number of if your number of inputs are high, then we can add more number of inputs to the PLC. And The PLCs are also basically classified based on their number of inputs they can hold and number of memory they are having. For example, the small size PLCs are there of having the 128 inputs and the number of bits they can handle at a time. So PLCs are also basically classified on based on that too. And this is the simple, you see there, one more thing is there, the supply is going from here to here and then getting into the PLC. This is the PLC supply, and this is exactly how the PLC looks like. This is the PLC, and we can program, this is that line from where the signal from the computer came and getting into the program, and we can program this PLC depending upon our operation. How we want this PLC to operate, we can operate this, and we can give it to the instructions. And for that, we are having a software in the computer where we can program the PLC, and the PLC works accordingly. So this is a simple, PLC circuitry and PLC unit. And in the next part, we will be showing you how it operates. And
hello, am I audible?
Yes, sir.
Okay, now the next few minutes will be for the programming part, and in that I will be discussing how we can open the PLC program and PLC software and how we will be doing the programming in that. So I will be playing that video. Okay, you just raise your hand if you have any doubts. You can ask me your doubts if you get one. So I will be playing the next video.
hello, dear students. My name is Imran.
Yes, sir, audible.
So today we'll be discussing how we can do the programming in PLC, how we can open the PLC, how we can load the programs into the memory of PLC. So first of all, you must be knowing that what the PLC is. As you know that the PLC is a programmable logic controller. It is basically a digital computer that is basically used for the automation of electromechanical processes such as control of machinery on factory assembly lines, or we can say amusement rides, or the lighting fixtures. So PLCs are basically used in many industries, and unlike the general purpose computers, the PLC is designed for multiple inputs and output arrangements. So right now I will be showing you how we can open the PLC and how we can do the programming here in PLC. The first step is we have to open the PLC program. So software. So I'm going to open the software. So TI is basically totally integrated automation. This is the software by Siemens, and I will be showing you how we can open this and how we can program it. So first of all, what we have to do is to create a new project. You see the option is there. We are creating a new project, and I'm giving the name of the project as anything like the PLC. I'll be writing here PLC program PLC program. Okay. So now I will be creating the project. This will take some time because it is creating the project right now. So see, now there are a number of options available there. So what we had to do, you see on the window, the option is configure a device, write a PLC program, or configure an HMI screen. So we can simply open the project view because we have already created it. Now what we have to do, we have to open it. After opening, you see on the left corner, there are a number of options available. We had to add a device. We had to connect this PLC to the computer. Okay. So There are a number of options available here as well, like schematic S7 1200. The CPU that is available right now with us is schematic S7 300, and I'm connecting this to the CPU. Okay, this one is available, right? CPU 314C. This one is available right now in the lab. So I will be clicking on this, and here what we have, the specifications are here. All the specifications like how many, like the frequency, input, whatever input you are giving, the ports, number of ports are available here. All the things are available. You see, after clicking on that, we have to add a new device. Sorry, there will be some option will be coming here. We have already added a device, and this will take some time because we are connecting the PLC to the computer. You see, the PLC, the CPU that we have selected is there right now available. Now we will click on this, and then after that we had to go to the program blocks, and then go to the main OP. This is how we can select now the programming window is here. You see, this is the programming window where you can program. Now in the programming section, there are so many options available. Okay, you can perform the basic operations, the bit operations. You can perform the mathematical operations. Okay, you see, I will go to the basic instructions. On the basic instructions, there are so many options available right now. Bit logic operations we can perform, timer operations we can perform, counter operations, comparator operations, mathematical functions, move operations, conversion operations, program control operations, word logic operations, shift and rotate operations, and so many other things we can do in the PLC programming window. Now, for example, I just want to do one thing. I just want to create a logic gate, simple logic gate in PLC programming. So for that, I have to go logical operations, bit logical operations. Okay, open the window. Now there are so many switches available. You see, this is a symbol for normally open switch, and second is a normally closed switch. Okay, and this is there are so many other switches available. Like this symbol is for the output. This one is for output. And this one is for output. You know, the output R. This will retain the output. Okay, the R is written here, and so many things are written there. Like these are some basic operations, like basic inputs, which are available there in a bit operations category. Now, for example, I have to design a simple AND gate. So for that, you know, for the AND gate, we need two inputs. I can select two inputs, like two switches I will select in terms of like, if I think in terms of mechanical things, I have to select two inputs. You see, now on the top, the switches are available, like I'm selecting the one more normally open switch, and I have to select the output. Okay, here I'm selecting the output as well. Now what I have to do, you know, there is some the red exclamations are showing here. This is just because I have not assigned any address to these inputs and the output. Okay. Now what I will do, I will go to the tag section. I will give the name of these inputs and give the address of these inputs. I will go to the PLC tags and show all tags, and then after that, there is I can give the name, for example, for the input one. For the first switch, I will give input 1, and then I have to select here. I have to give the address here. This address is basically being specified by the company. Like for example, the Siemens, they have written it that give the address 136. Okay, I am writing 136 here. So you see here operand and identifier. What if this will do? This I is for the input and Q is for the output. Okay. Now I am defining those inputs here. And I will define one more input here. This is a very basic, very simple programming. You see, two inputs I have defined it here. Now I have defined one more output because there is one output and two inputs. I am defining one more output here. That is output. And here I have to change the identifier. Address will be same. Bit will be different, but this operand identifier will be different. Okay, Q is for output. Okay. Now I am giving a bit number 0 for the output. Output 1. I am giving the bit number 136.0 will be there. Okay, clicking on it. Now going back to the main operation window. You see, now right clicking on these options, what I will do, I can add the those addresses to these inputs. Okay, now I'm assigning this as input 1 with the address and this as input 2 with the address. Okay, now I will assign the address to the output as well. Now after that, now this is called as a rung. One line of program is called as a rung in PLC. Okay, this is the one rung. Why it is called as a ladder programming? Because you see, when I will add the number of other programming lines, it will look like a ladder. That's why it's called a ladder programming. Okay. See, now after I had designed a one AND gate. Okay. Now after doing this, I had to compile it to check if there is any error. Now I'm compiling it. This will show no error. Okay, since the circuitry is, the programming is okay, it's showing 0 warnings, it's showing that there is no error into the programming. So what I will be doing, I will be loading this program to the PLC memory. So I have to click here. This will take some time because I am loading this into the memory of PLC. You see, now here it is showing me that you have to connect to the PLC to the computer. Now there is I'm selecting here. This is here I'm selecting the PLC. Now the computer is communicating with the PLC right now. Both are communicating. Now after this communication is done, what I will be doing, I will be loading this program into the memory of PLC, and then the PLC will operate. You see, there is this I am turning on. This is the monitoring on and off. But with the help of this option, I can see up to what point the output is going here. My output is going. Sorry, my input is going there. Okay. You see, after turning this on, this will be this will show me this green line. What this green line is showing that the signal is going up to this point, or my input is going up to this point. Since the switch is off, the input is not going beyond that point. And you know, in the AND operation, by both the inputs should be high. Then after that, only my output will be there. Now, this is simply, I have designed a program. I have programmed a PLC in this way. Now, when I will be turning both of these inputs on, then only that my output will be there. So first of all, I will be showing you this on the panel. I have programmed the PLC right now. Now I will be showing on the PLC, this panel, how this will be working. Okay, you see, there are a number of inputs available. I have selected these two inputs. This is my input 1, this is my input 2, and these are my outputs. Okay, now in the first of all, I will be showing you here when I have programmed the PLC that when both the inputs will be high, the output should be there. Okay. Now, if I am pressing only one input, the output is not there, and I will be showing you later on the programming line as well how it is working there while pressing this, how this is working on the program in the PLC. When I am pushing only this one, the output is not there. But when I push both the buttons, the output is there. You see, this is how the PLC is being programmed, and now it is working accordingly. Okay, you see, when both of my inputs are high, the output is there. This is the simple AND operation. Now I will get you back to the programming line. You see, this is my programming line. Okay, this is how I programmed the PLC. Now I will be turning on. I will be doing this. I will be showing you here on the computer, but I will be pressing both the switches. Okay. Now I am pressing switch 1. The output is going to this point. Now I am pressing switch 2. You see, when both the inputs are high, the output is there. You see, that is what I did in the programming, and the PLC is working right now accordingly. Okay. I have shown you. Right now how the output is showing high there. Okay, this is how the PLC programming we can do. Now we will be designing one more like OR operation. Okay, for the OR operation, you know, when both the inputs, any of the inputs is high, the output will be high. Okay, for that two switches will be in parallel. I am making that programming. Okay, now assigning that as input 1, assigning that as input 2. Now in the PLC programming, you know that any of the inputs in the AND OR operation, when any of the inputs is high, the output will be high. Okay, see, now I will loading this again to the computer, to the PLC. Now PLC is doing programming like this way only, that when both the inputs are when any of the inputs is high, the output will be high. You see, now first of all I will be showing you there. When any of the inputs, these are my two inputs. This is my input 1, this is my input 2. When any of these inputs is high, the output will be high. This is my output. Okay. Now I will pressing 1, the output is high. Pressing 2, the output high. Both are high. The output is high. Okay. This is the AND operation I have performed. Now getting back to the PLC programming, I will be pushing again both the two push buttons, and it will be showing the output here. Okay. You see, now I am again pushing those similar buttons. So I am showing you now here on the this PLC programming, like I am pressing input 1, the output is high. Pressing again the input, the output is high. When I am pressing both, the output is high. This green line is showing me that the signal is going here. Okay. Now this is the other gates you can design like this only. This is how we can make the gates do the bit operations in the PLC programming. Now one more thing we can do is that, for example, I just want do the timer operations in the PLC programming. What will the timer operation will do? For example, I want that after turning the switch on, my output should be turning on by after some delay. Okay, the delay we can give here in the PLC with the help of timer operations. You know, I'm clicking on the timer. There are 3 types of timers available. Like, so the timers are available here, like timer on, timer off. What I will do with these timers, for example, I am selecting the on timer here. I will show you with the help of example. Okay, I'm showing you. You see, the timer is here. What I want now is that, for example, I'm removing one input. For example, you can add both the inputs. Okay. For example, I have the normally open switch here. For the normally open switch, I have to click it. I have to keep it clicking so that you can get the output. Now I just want, for example, after the delay of 10 seconds, my input should be on. Okay. For example, I'm giving the 10 seconds delay here. After I have to load it. Now I have programmed the PLC this way only, that after clicking the switch 1, my output should be there after 10 seconds. Okay. Now what I will be doing here, I will be showing you here. See, you see, after the 10 seconds, I have just turned on this input on the panel. Now after the 10 seconds, this will be the output will be high. You see, the output is high after the 10 seconds only. This is how, for example, you want the motor to be operated, to be on, for example, you are pressing the button and you want that your motor should be turning on after the delay of 10 seconds. For that, what you have to do, you can add a timer, and with the help of timer, you can press the switch, this push button, and this input, this input, and after the delay of 10 seconds, the output will be on. Okay. Now see. This is the, I have already shown you on the PLC programming window. Now I'll be showing you here. You see, this is the input, this is the output, this is my input. Now when I am pressing this input, after the delay of 10 seconds, my output will be high there. Okay. Now I am pressing this input. You see, this is not turning on quickly. This will turn on after the delay of 10 seconds. Okay. You see, after the 10 seconds, the output will be high. Okay, you see, after the delay of 10 seconds, the output is high. When I am dropping this is turning off. Okay, now when I am again pressing it, this will turn on after the 10 seconds. Okay, you see, after 10 seconds, this will turn, because I have programmed my PLC like that only. Okay, this is okay, the output is high here, and you can add the down counter. Off timer as well. That works in an opposite manner to the on timer. Okay? Now see, so this is the timer operation. Now I just want that I just want to perform the counter operation in the PLC. Okay. For example, now what I will do, I will add one counter counter operations. I just want that after pressing the push button 5 times, up timer, I'm using up timer. I just want that after pressing the push button 5 times, then only that my output should be high. Okay, you see, for example, I am adding here the up timer, up counter. Okay, clicking this, you see what I am doing here. For example, I am giving that 5. This 5 will show me that after clicking the input 5 times, then only that my output will be high. Okay, for this I am like adding the one more input here, so that this will get the 5 pulses. After the 5 pulses, my output will be high. Okay, you see, now I'm loading this program again. I'm loading this again. Now I have programmed in my PLC like that only. You see here, this is on. I'm again, first of all, I'll be resetting it. You know, this was not I have not resetted this. Now what has happened? For example, when I will turn the input on, the output will be high only after pressing the switch for the 5 times. Okay, 1, 2, 3, 4, 5. Wait, there is some reset. I have to reset it. Sorry, there was some problem. Okay, now again, 1, 2, 3, 4, 5. The output is high. You see, the output is high now. Again, turning the reset. Now 1, 2, 3, 4, 5. The output is high. You see, the output is high only after the 5. But now, for example, if I want to reset it again, reset. Okay, I will show you now. This is the same thing I will show you on the PLC panel. Okay, because I have designed my PLC this way. Now, what this PLC will do, when I am turning on this 5 times, then only my output will be high. The PLC will count the number of pulses I am giving to it, and after those